Alright, we're still on this section, transversals and triangles. So we looked at transversals yesterday. Today, when I look at triangles, and they pretty much are, it's triangles that have parallel lines in them. Just turn on that light there. And when you have parallel lines running through triangles, it splits the triangles into similar ratios. So this yellow box is really important. If you have a triangle with two parallel lines, the ratio of this compared to this will be the same as the ratio of this to this. The ratio of the long side here to this side will be the same as the long side here to this side. And the same way, the ratio of the long side to here will be the same as the ratio of the long side to here. And also something they don't mention, the ratio of these two lines will obviously be in the same ratio as the rest. Okay, so we're going to do a couple of examples. I'm going to do the example from the book and one other one. And please do ask about this one, because again, some people find this quite difficult, some people find it quite easy. This is the example from the book. So I'll turn off that now. So it has this. It says BD is 8, DB is 4. They have the whole thing, AC is 9, and it wants to find AE. So to be honest, what I do is I look and see what I'm looking for first of all. So we're looking for AE. We're looking for this in here. So I would say this is obviously part of the smaller triangle, whereas this length here is part of the bigger triangle. So where it's beneficial to me, I split this into two triangles and go back to my knowledge of similar triangles. So this is the triangle DAE, where this is 8 and this is X. And then I look at the bigger triangle as a whole. Okay, so there's no point in me comparing. Well, you could do, there's another way of saying that's double that, so this has to be double that, and then looking at 9. But I actually look at it a small different way. I draw the big triangle now, because they're similar triangles, because that angle is equal to that angle is equal to that angle is the same in both of them. So this is this triangle BAC. This length here we know is 12 because it's 8 plus 4, and this in here is 9. And now we just have two similar triangles, and I know that the ratio of this triangle is the scale factor, where the ratio is 12 divided by 8, which is 1.5, and I know this is smaller than this, so 9 divided by 1.5 is equal to 6. Sorry, 8. 1 second there, I just want to get something right here. Sorry, it's not going right there. So yeah, 9, like I said, 9 divided by 1.5 is 6. So that side there is 6. Now again, like I said, you could have compared. So what I've done there in terms of the book, in terms of these, I've compared the long lengths with these two short lengths. That's the one I've done. But I've just split them up into two separate triangles. I just find it easier. A small triangle and a bigger triangle. Again, sometimes it will work, sometimes it won't. So if we look at this next one, this isn't in your book. So it's another triangle, parallel lines. So this triangle is similar to the bigger triangle because again, that's the same as that. That is the same as that because they're upside down F angles, parallel lines, and that is obviously the same as itself. So what I do is I redraw smaller triangle. Again, DBE in this case. This is 9 down the bottom. And the bigger triangle, scroll down, the bigger triangle is ABC, and we know that the bottom of the bigger triangle is 12 and this side of the triangle is 10, and we're looking for DB, we're looking again for the smaller one. So I find the relationship between two corresponding sides of the ratio, so that, and I call it the scale factor, is equal to 12 divided by 9, because the ratio is 12 divided by 9, and 12 divided by 9 is equal to 1.333. Now be careful, it's continued, so don't just multiply by 1.3 or divide by 1.3, it's 1.333. So it's 10 divided by 1.3333. Again, whenever I'm typing that into a calculator, I literally do 10 divided by 1.333 7.5. And the reason we're dividing is because obviously it's smaller. So that's the way I personally do it. You don't have to. If you have another way of doing it, there are other ways. But I split it into two triangles where I can and work back to the way we did it for similar triangles. I look at the smaller triangle on top and the bigger triangle. And some of these questions are a bit tricky, so if you have any questions, can't get the answers, please ask.